While electric vehicles are all the rage now, there's a new disruptor on the horizon that could make EVs obsolete overnight. Toyota is quietly working on a groundbreaking innovation so radical it'll change the way we fuel our cars forever. Their top secret project? A water-powered engine that's about to make gas and batteries extinct. Get ready to ditch your Chargers, because Toyota has cracked the code to run your ride solely on H2O. This could deliver the final nail in the coffin for the entire EV industry. Are you ready to say goodbye to gas stations and plug-in outlets? Toyota is unveiling the automotive holy grail, an engine that runs on water. Toyota, as a trailblazer in the electric vehicle industry, holds an unwavering commitment to innovation at the core of its ethos. For Toyota, innovation isn't just a buzzword, it's their sole focus. This forward-thinking mindset began to bear fruit in the 90s when the concept of electric vehicles was still in its infancy. During this backdrop, Toyota boldly introduced the world to the first hybrid electric car, the Toyota Prius. This groundbreaking move effectively catalyzed a new era for EVs within the automotive market. Many experts speculate that without the remarkable success of the Prius in the late 90s, Tesla might not have gained the initial push it needed in the early 2000s. Regardless of the circumstances, Toyota wasn't content to rest on its laurels. In today's automotive landscape, dominated by giants like Tesla, Ford, Chevrolet, and Fiat, Toyota is sometimes seen as a less dominant force. However, it remains a significant player. Remarkably, 1 in every 5 off-road vehicles in America is a Toyota, reflecting its enduring popularity. Despite the success of the Prius and its global feedback, concerns arose about flaws in their hybrid electric engine. Consequently, production of their electric vehicles was halted. Yet, Toyota remains undeterred in its pursuit of innovation and continues to strive for excellence in the electric vehicle domain. The flaws that plagued Toyota's electric vehicles were more than mere hiccups. They were fundamental challenges that couldn't be easily rectified with minor tweaks. Upon closer inspection of their EV model, the Prius, Toyota identified 2 significant issues. Firstly, despite the eco-friendly image of electric vehicles and their touted zero-carbon emissions, the electricity supplied to charging stations often originates from coal, diesel, and natural gas sources. This paradoxically makes EVs indirect contributors to environmental pollution. Secondly, the batteries that power electric vehicles predominantly rely on materials like lithium, cobalt, or nickel, each requiring significant extraction efforts. The extraction process demands a substantial amount of fossil fuel, equivalent to that required of 2 conventional EVs. Surprisingly, an electric car emits approximately 13,608 kilos of carbon dioxide gas before it even arrives at the showroom, a figure that could potentially contribute to the premature deaths of 22,000 individuals annually. Toyota realized that these flaws undermined the primary goal of electric vehicles. They were using rare materials unnecessarily, merely for convenience. Consequently, Toyota took a step back in EV development and shifted focus to improving cars with combustion engines. This began with rethinking fuel choices. Toyota has always understood that the type of fuel used matters more than the engine itself. Factors like ease with which chemical bonds in a fuel can break to release trapped energy and how many of these bonds contribute to carbon emissions are crucial considerations. Carbon's ability to form the most bonds is a key element here. So what's the alternative? Toyota pondered the idea of utilizing hydrogen as a fuel source. Hydrogen molecules consist of 2 hydrogen atoms, and due to their small size, they can be densely packed in a fuel tank. This could potentially yield more energy efficiency compared to traditional fuels like petrol. Furthermore, the bonds between hydrogen atoms are incredibly robust, resulting in 3 times more energy released than petrol when broken, all without emitting carbon dioxide. Overall, this presents a significant win-win scenario. Toyota has already developed a hydrogen engine, as supported by our detailed explanatory video. However, as highlighted in the video, hydrogen-powered engines face challenges. While hydrogen stands out as a promising fuel alternative due to its clean emissions profile, its highly flammable nature poses significant safety concerns, especially during transportation in large tanks. Imagine a fleet of hydrogen-powered vehicles navigating the congested streets of New York City. It's not just congestion, it's akin to a ticking time bomb. This realization led Toyota to initially abandon the concept of hydrogen-powered engines. However, they eventually circled back to the drawing board, determined to find a solution. So here's the deal. Toyota figured out that to make cars that are genuinely good for the environment, they need to look beyond just fossil fuels. They recognized that hydrogen could be a good alternative, but there's a catch. Pure hydrogen is highly flammable. However, if they could somehow make hydrogen less pure, it wouldn't be flammable anymore. That's where the concept of a water engine came into play. Instead of using pure hydrogen, they use a mix of hydrogen and oxygen from water. This mixture wouldn't be flammable like pure hydrogen. This whole concept teaches us an important lesson. When we face problems, we shouldn't just panic and give up. Instead, we should innovate and find creative solutions, just like Toyota did with their water engine. Toyota's engineers faced challenges with traditional electric and hydrogen engines, prompting them to explore a new approach, a water engine. They found that impurities in water, like oxygen, could make hydrogen less explosive, while others had attempted water-based engines before. Political interference and impractical designs hindered progress. Stanley Meyer's water-powered cars showed promise but faced opposition from oil companies. Despite setbacks, Toyota's engineers persevered, blending the strengths of various engine types to create a versatile and efficient water engine. This innovative solution paved the way for more sustainable automotive technology. Toyota channels water into hydrogen through a process called electrolysis, where water molecules are split into hydrogen and oxygen. This hydrogen is then collected and pumped into the vehicle's tank for use as fuel. To mitigate safety concerns associated with handling hydrogen, Toyota integrated the hydrogen production setup directly into the vehicle itself. Instead of storing inflatable hydrogen in the tank, the vehicle carries plain water, performing electrolysis on demand using onboard battery power. This innovative approach minimized safety risks and maximized efficiency, showcasing Toyota's knack for leveraging different engine technologies to overcome weaknesses. Toyota's commitment to innovation traces back to Japan's post-World War II era, where the country focused on innovation to rebuild. Toyota, originally a handloom manufacturer, learned to make cars with support from the US, emphasizing innovation to create sought-after products. This legacy drives Toyota's pursuit of groundbreaking technologies like the water engine. The big question remains, can Toyota's water engine compete with the electric vehicle industry? While still in the prototype stage, Toyota faces challenges such as energy conversion efficiency and affordability. However, with ongoing innovations, like an efficient electrolyzer, there's hope for overcoming these hurdles. Toyota's backing and commitment to innovation position the water engine as a potential competitor in the automotive market, sparking curiosity and expanding knowledge in the quest for sustainable transportation solutions. However, challenges remain, and the question of whether the water engine can compete with electric vehicles looms large. What do you think? What innovations do you envision for the future of sustainable transportation? Let's spark a conversation in the comments below.